Dewan said, you guys are going to have some high quality speakers. That happens after me. So let's just get through this and I'll try not to put you to sleep, okay? All right, so as I briefly mentioned, I've been in IT for over 20 years. I spent a large part of my career working in government, federal government contracting. I can list off all the alphabet letters, DIA, DOD, GIFCOM, MISIC. But I spent 5 years at the FBI, where I was working as a special advisor to the CTO and CIO. I was promoted to an acting assistant section chief. And then after that, I became a unit chief running the FBI's email, database, virtualization platforms, and helped get the Sentinel case management system across the line. Eric may not be too happy about that, but at least we got rid of ACS. I've been at the NCAA for a little over 6 years now, and I have loved every minute of it. When I came to the NCAA, I walked into a very immature IT shop. But over the last couple of years, we've worked really hard to transform ourselves into that data analytics, data-driven organization. I'm going to talk a little bit about that. But first, I want to talk a little bit about what is the NCAA. Despite what you may hear from the media, let's kind of go through what it actually is. So we are actually a nonprofit membership association. Our membership is made up of the U.S. colleges and universities and conferences. We work for them. They're our client and also our boss. Our primary mission is to regulate college athletics, to ensure level playing field, and to help promote student-athlete graduation rates. So if you look at the scope of what the NCAA actually covers, we have 90 different championships that we sponsor. Obviously, the most familiar one is the D1 men's basketball tournament, March Madness, Final Four. That's the one that everyone kind of knows us for. But we have 89 other championships in 24 sports across 3 divisions in male and female. Under our purview, we have almost 500,000 student athletes that we're responsible for. And we do all of that with a staff of 500 folks here in Indy. And if you want to do a comparison, if we want to look at the NFL, they have in their national office headquarters, their staff is a little over 2,000 folks. They have 32 teams they're responsible for. We have over 19,000 teams we're responsible for. And we do it with 500 staff. If you want to see the breakdown of kind of what the NCAA consists of, you can see the 2 important numbers are in the bottom right, the 497,600. Those are how many student athletes we're responsible for. And then the number of NCAA members on the far right, the 1,244, that makes up our membership. And that's who we work for. So what have we been doing with data analytics, big data, advanced data analytics, all that stuff? One of the biggest things that we have done is that we have created a new tool called NET, the NCAA evaluation tool. And it all started with a project last December, January, where we started working with Google Cloud and thought, hey, it would be a great idea if we could get all the play-by-play data for all the D1 men's basketball games going back over a decade. And that is a lot of data. You're talking about 350 plus teams. They each play anywhere between like 25 and 30 games a season, and then the play-by-play data from that, we all threw into BigQuery. And from that, we were able to find quantifiable success factors. What variables make teams successful? And so we can quantify what that means. We can quantify the value of a road win for D1 men's basketball. And we use those variables to come up with a new algorithm, machine learning predictive analytics ranking system. Because for the past 30 years, we've been using something called the RPI, the Ratings Percentage Index. And we use that when we have 360 teams. One of our biggest goals is to figure out who are the top 64 teams who are going to make our tournament. And then how do you compare the Florida State versus Southern California when they haven't played each other and they have no common opponents? How do you compare those two schools? And how do you ensure that you're getting the high quality teams who are supposed to be in the tournament to also have a highly competitive tournament? So using this data, we were able to come up with better means and mechanism to say, hey, we think this is a much better predictor than what the RPI is. So we worked closely with Google. We came up with it, we tested it, and then the basketball selection committee decided that we're going to use NET and replace the RPI. So one of our biggest projects, one of our highest visibility initiatives, we are now running off of NET, off of machine learning. And so one of the fun stories that we had as we were looking through our data, it was giving us insights we never had before. We were able to learn that the likelihood of an upset increases when there's a full moon out. I know correlation is not causation, I understand. We also found that mascots that were cats also had a higher likelihood of upsetting the other team. So some of it's interesting, maybe not so useful, but very interesting. So when we finished this initiative, we decided, hey, before the tournament started, let's use NET and let's see how good it is. Let's predict how we think the tournament's going to play out. So we had our team together and we ran the simulation. Who all watched or participated in an NCAA pool last year? Fair number of hands. Who predicted UMBC to upset Virginia? I don't see, no, see, I think you're lying. You're lying, come on. There's no way. Okay, so the number one team in the entire nation was Virginia. And basically the number 64 team who barely got into the tournament was UMBC, and they were scheduled to play each other in the first round. And nobody thought UMBC was going to win. Nobody. So we did our simulation, and we thought this will be great. We'll post it on our website to show, hey, Google's helping us do this, and here's the machine learning ranking. Well, in our simulation, it showed UMBC beating Virginia. And so we posted it for about 30 seconds. And we had folks who were like, there's no way this is going to happen. This is such a no-brainer. We've got to take this down. This will be embarrassing for us if we leave it up. So we took it down. And then sure enough, UMBC went on to beat Virginia. So it was a very interesting moment to see that, hey, the data actually called it. We didn't trust the data enough to go with it. And honestly, it probably worked out for the best, because if we posted it and then the upset occurred, people would have thought there was some giant conspiracy going on with the NCAA. So I'm actually kind of glad we pulled that down. But still, nonetheless, it showed the data's onto something. And it actually brought a lot of credibility across the NCAA because we called it. So that's just an example of one of our biggest initiatives that the NCAA does. We're now turning over to machine learning. And again, this is not deciding the teams. This is a way to assist the selection committee. The selection committee is still making the final call, but NET is a great way to help give them some of that extra data to maybe make some of those comparative analysis. So what else did we do with this initial project? So we decided it'd be a good idea to increase the fan engagement, to have predictive ads. So if you watch the Final Four, you might have noticed at halftime, well, you probably noticed a lot of NCAA Google Cloud commercials anyway, but at halftime, we decided we were going to make a predictive ad. So based on the stats of the first half of the game, we made some predictions on what was going to happen in the second half, and then aired that commercial during halftime. So very real time. And then here's what that commercial was. Let's hope the audio works. There we go.
It's going to be
All right, so that aired at halftime of the Final Four. So how did our predictions do? So we made a couple predictions on the last 3 games. And you can see the very bottom is the Villanova-Michigan game. And I've got highlighted the number of total 3-point attempts. We were 76.4% sure it was going to be 21 or greater. Our exact estimate was that there were going to be 24 attempts, and the correct answer was 24. We also predicted that there are going to be 135 combined possessions. The actual number was 134. So we were pretty close. So we were pretty proud of how we were able to use the 10 plus years worth of data and just on that one initiative, what we can do with it. And I'm going to talk a little bit later about some of the next steps on what we're doing with that data. So obviously we were using this for one of our biggest public facing, our biggest events at the NCAA. I also figured I'm going to bring it back to a project that we're doing internally that a lot of people are not going to see. So we're currently working, we just finished up a pilot for our eligibility center transcripts. So every year we get around 250,000 high school seniors who have to apply to the NCAA so we can academically certify them to be collegiate student athletes. And that all goes through our eligibility center. So when we're certifying these kids, we get their transcripts and test scores. Well, right now, when we get a transcript, we have someone manually take it and then input it into the system. It takes 9 minutes per transcript. When you're talking about 200,000 plus transcripts, you can do the math. That's a lot of time and a lot of money. So it started with the conversation with Clear Object and Google Cloud to figure out, hey, how can we use machine learning, advanced data to help us with this process? So we came up with using Vision API, AutoML, and the foreign language auto-translate to basically read the transcripts and input into the system. We just finished up that pilot result. So initially, it took 9 minutes to do one transcript. At the end of our pilot, we did 10 or 12,000 transcripts in 35 minutes. That is a huge ROI. And that, you can also do the math and kind of figure out, if it was 9 minutes per transcript, 200,000 plus transcripts, how many minutes, how many contractors was that costing us? You could do the math to figure out the savings on that for us. Now I'm going to reference this project a lot on my next slide, so I'm not going to delve too deep into this. But again, looking at we went from the highly visible to the really internal operations that not a lot of people are going to see, how the NCAA is starting to leverage this. And as it was noted earlier, we're just getting started. We're looking at big data for health. We're looking at it within esports. I mean, we are looking everywhere. Where can we go next? So here are just a couple examples. But as we have been going along this path, the culture of the NCAA is very interesting in that it's not a very technology-driven organization then. It's becoming more so. So we always, in IT, always encountered resistance. And so how do we push this in the organization for the good of the organization? So I came up with a little chart to talk about the stages of adoption and maybe give you a couple tidbits you can walk away with in your own organization. So I hope you guys can see this. So across the top, the stages of adoption, and I've got stage 1 through 4. So I view it as this can apply to business units. This can apply to your peers in the business units. This can even apply to your boss. You need to figure out what stage your user, customer, whatever you want to call it, your partner, you have to figure out what stage they're at. So we're going to go across the top. So the first horizontal is their behavior. The behavior is the best indicator to figure out what stage they're at. We have a lot of people who are in stage 1. And what that means is that there's avoidance. If you ask them about, hey, can we help you with data analytics? The answer is going to be no. High level of skepticism, but the no is almost immediate. They don't want you into their stuff. They don't know what you're doing, so they're scared. And as you go across the stages, it turns into a little bit more skepticism. Stage 3, they're warming up to it. Okay, this is okay. I can deal with this. Stage 4 is the fun one. This is when they're excited and they're bringing new ideas to you and asking you questions. And in fact, they're bringing you stuff that's not even technically possible yet because they're so excited. Like, hey, can we just set up a camera and just have it auto-collect stats from a game? I don't know if that's possible yet, but that's a great idea. So you want to try to get, your overall goal is to get people to stage 4. Now, if you go on their view, what is their view of what you're doing? In stage 1 and stage 2, it's nerdy. It's foreign and it's nerdy, okay? And as they warm up, it's kind of cool, and then at stage 4, this is awesome. And they start trying to use the terminology back to you. Often it's not right, but it's cute that they try. A lot of my staff say that about me, so it's okay. So they've got that shift. Okay, so your approach, the third line, this is what you can do to help people get from stage 1 to stage 4. The first step, if you find someone in stage 1, you do it anyway. You know? So you sell the benefit and you start small with a strong return. So that EC transcript project, I just did that. I had some money left over at the end of the year. I think this would be a great business case. So I just started doing a pilot. And then once I saw that it was feasible, then I brought in the EC and I sold them the benefit. Hey, you know, I was just doing this pilot. If it fails, that's okay. But what I found is I think I could save you a lot of money. Are you interested in saving a lot of money? No one's going to say no to that. So I just went ahead and did it. And again, I think this can work at all levels. Whether you're the CIO or it's your second day on the job, hey, I think I could do something with machine learning on this little project. Let me do it on the side. Let me see if I get a good result. And then let me go out and sell and get other people involved. Because once you can prove, hey, I think this is feasible, you're going to get people excited. And then as you go across, stage 2, you're still selling the benefit and you're listening to their concerns. Stage 3, that's when you become the partner with them. And then ultimately stage 4 is when you're not selling anymore. You're listening, you're assessing. And stage 4 is when you look at the major projects, the game-changing projects, because you have excited advocates with technology you've already proven. That's when you really start doing some cool stuff and really start transforming your organization. Okay, so I put language up there. This is what language do you use when you're talking to other folks? And it's the same across all 4 stages. You speak business. Do not use technology terms. If you're in a meeting with a business unit, someone outside of IT, and you use the phrase structured versus unstructured data, IoT, deep learning, just stop. Just stop. Just use business terms. That's all they know and understand. If you talk about the nuances of machine learning versus deep learning, they're going to stop listening and you lose some credibility. But if you can use terms that they want to hear, hard numbers is always great. Efficiency is always great. Improved accuracy, like on the EC transcript project. Hey, I could save you $300,000. I can improve your accuracy and make you look really good. They're going to be more open to it. So always speak business. After implementation, it's also the same across all 4. Market your win and share credit. IT does a really bad job of marketing their win. We do some really cool stuff with tech, and then that's what we brag about. We brag about the tech. You need to market the business value you just brought to your organization. Hey, I just saved $300,000 with a couple months worth of work. And that's $300,000 every year. That's great. That ROI is huge. That's what the CFO wants to hear. That's what the CEO likes to hear. If you start going into your CEO, hey, you know, we just did this machine learning thing and we used the disparate data sets, they've already tuned out. Okay, so why is your ultimate goal to get to stage 4? because of their value, either the business unit, the other VPs, other peers. If they're in stage one, they're working against you. It's not neutral. When the VPs are having meetings and they're saying, hey, should we bring IT to the table? All the stage one people are going to say no. So you have to identify and target those stage one opportunities to start converting people to become your advocates. You cannot have detractors in what you're doing. So stage one, they're negative. Stage two and stage three, they're kind of neutral. Yeah, we'll see how this pans out. In stage four, they're advocates. They're going to bat for you. And when they have that big table with the VPs and they're talking about a problem, the advocates are going to be saying, you know, IT really stepped up and saved me 300 grand. I think we should get them involved in this conversation to see what they can do. So your ultimate goal is to get people to that stage four. And again, your approach, that's how you do it. And you're going to have to take a couple risks on this. All right, so if I had to sum up kind of the marching orders, these are things I want you to start doing today. Start doing right now. Number one, be bold. If you are waiting for the CEO or president to come into your office, your department, and say, hey, we're going to be data analytics first, machine learning is going to be everything, we're going full bore into this, you're going to be waiting a long time, unless you have a rare exception. It's not going to happen. If you're waiting for your business unit to come to you and say, hey, I've got this great data, I think machine learning would be great to use on this, it's not going to happen. You have to go out and you have to start doing it. Increase that adoption, and then it's a snowball effect. It's going to build. All this happens when you understand the business. The business units aren't going to understand the capabilities of data analytics. They don't understand what exactly machine learning is. You do. And you're learning that at conferences like this. What are those new technologies that are out there that I can bring back to my organization? But if that's all you do, you're going to sit at a table with the business unit, and you guys aren't going to be able to talk to each other. You need to be able to understand what's happening in that business unit, where are their problems, where are they spending their money, where are their inefficiencies, where are their employees, where are the cluster of employees. So you could say, hey, you know what? I know that you manually process 200,000 transcripts. I think we could do machine learning to automate that. So you have to understand what's happening out there, because it doesn't matter how much technical knowledge you have, if you can't apply it, it's almost worthless, right? So you have to figure out where you can apply it and understand the business to do it. Speak business. Again, you can't go in talking about technical terms. You have to sell the benefits to them. Why are they going to be interested? How is this going to make them look good? And then hard savings. You know, one of the political strategies I took was getting the CFO on board with what I was doing. And I went to her with the EC project. Hey, I think I could save $300,000. Can I just get half of that back? And she said, yep, that's a great idea. You just saved 300 grand. I'll give you 50%. And in fact, she also said, I want to see more innovation stuff from you. How about if I give you another $100,000 for an innovation budget? What do you think I said? Yeah, I said, yep, I will take that. But because I'm speaking business, I understand what they're going through, and I'm using terms that everyone understands. And the CFO is now marketing on my behalf to our president. Hey, you know, IT just saved $300,000. IT just helped with net. We're looking at some other things that are another project that we're hoping will save between $4 and $10 million a year. They're excited. Sell your value. One of the things that IT is really bad at is saying, hey, we did a good job. We did this. And people underestimate IT and the capabilities that we provide. So no one else is going to speak on your behalf. You have to be your own marketer. You've got to get out there and say, we did this. We saved money. We increased accuracy, efficiency for the EC. And we're doing a better job for the applicants. We're speeding up the entire time for them. IT did that. So you have to make sure you are out there doing that. We all know the phrase, you got to toot your own horn. You should be conducting your own orchestra, because that is much louder than a little horn. No one else is going to do it for you. So to wrap up, you guys just have to start doing it. Go out there, speak business, and then sell your benefit. What questions can I answer for anybody? All right. Well, thank you very much. I appreciate this, and have a great day at the conference.